This example is going to allow us to apply the mean value theorem for integrals. Find the average value of f on the given interval, and our function is f of x equals the cube root of x. Interval is 0 to 8. Then find c in the interval such that f at that c is equal to the average value of the function, and then we're going to draw a graph. I'm probably going to use Desmos. Part A. We want the average value of the function over the interval from 0 to 8. So 1/8 times the integral from 0 to 8 of x to the 1/3 dx. That's going to be 1/8 times x to the 4/3 with a 3/4 out front, evaluated from 0 to 8. And I'm actually going to do this because I want to remind you how to deal with rational exponents. 8 goes in place of x, and in the exponent 4/3, 3 is a cube root. So the cube root of 8 is 2. 2 to the 4th power is 16. So we have 3 over 32 times 16. That's going to give me 3/2. There's our average function value. Part B. Find c in the given interval such that the cube root of c in this case is equal to 3/2. Well, that would imply that c is equal to 27 over 8. Now that's the answer, but for graphing purposes, I'll say that that's 3.375. You know, I said I would use Desmos, but I'm looking at this and it says sketch. So we're going to draw a sketch. We're going to sketch a graph of f on the interval from 0 to 8 and then a rectangle. Okay. All right, so here's my curve, the cube root of 8 as x goes from 0 to 8. And then we were told, this is kind of weird, to sketch a rectangle whose base is the given interval, so from 0 to 8, and whose area is the same as the area under the graph of f. Folks, that means the height of this rectangle is supposed to be 3/2. That looks like it's at about 1.5. And look at this. We are intersecting the curve at about 3 3/8. That seems to make sense to me. Anyway, the claim is that the area of this rectangle is the same as the area under this curve from 0 to 8. Last up, find numbers b so that the average value of the function f of x equals 2 plus 6x minus 3x squared on the interval from 0 to b is equal to 3. Just a reminder, the average value of a function formula is f average is 1 over b minus a times the integral from a to b of f of x dx. Here we are given that the average value is equal to 3. And then we're looking at the interval from 0 to b. So 0 to b. Notice, because we have an interval, and an interval has an orientation, b has to be greater than 0. I hesitated because I was going to say greater than or equal to, but if b was equal to 0, then I would have no width, and there's no way that the function would have an average of 3. So b has to be strictly positive. 1 over b minus 0 as a coefficient out front is 1 over b. And then we have here 2 plus 6x minus 3x squared dx. And we now have an equation, and the number we're solving for, or the variable we're solving for, is the upper limit of integration, and also in the denominator of a factor. It's kind of weird. We'll say 3 is equal to 1 over b times 2x plus 3x squared minus x cubed, evaluated from 0 to b. Look, b is going to replace all of the x's, and then we're going to divide out a factor of b, right? So I have 2 plus 3b minus b squared is equal to 3, which means that b squared minus 3b, what is that, plus 1 is equal to 0. Well, that's nasty. Let's use the quadratic formula. And we get b could be 3/2 plus or minus the square root of 5 over 2. Quick check, I want to make sure that b is going to turn out to be positive. I know that 3/2 minus the square root of 5 over 2 is positive because 3 is the square root of 9, and square root of 9 is bigger than the square root of 5. So I'll just tidy this up by saying that that equals b. And we're done with that, but does this make any sense? Why are there two numbers? I have here the graph of our function, y equals 2 plus 6x minus 3x squared, here in blue. Now remember our interval started at 0. And first we have x equals 3 halves minus the square root of 5 over 2. And so the statement is that over this tiny little interval, the average value of this function is 3. Switching this up, again starting at 0, this interval to the vertical purple line, which is at x equals 3 halves plus the square root of 5 over 2. Look, we have some positive values, we have some negative values. Over that interval, the average function value is 3.